So this coming section of the video may be quite slow or boring to many of you, but going through the pins which are on our ECU and what each one associates with help us gain a better feel of what sensors are in our car and how they interact. So feel free to skip it if you're only specifically interested in installing the Defi system, but if you are interested in how ECU connectors work and what signals come out and go into them, hopefully this section is of some interest to you. Okay, so drawn here is the first of the ECU connectors. So this is what is known as ECM connector A. So what this is related to is this works with your injectors, your O2, your evap sensors, you've got stuff like VTEC solenoid control, aircon control, all those kind of things. So starting from the top left and working to the bottom right, we're looking at the first four wires are your injectors. So there is one per injector, and this is what sends an output signal to have them actually pulse fuel into your engine. Moving along, there is two related to your O2 sensors, so secondary O2 and primary O2, followed by your EGR control valve, which is your exhaust gas recirculation valve, which basically takes a small amount of exhaust gases and recirculates them through the intake to be burned again. This is related to emissions. Following that, we've got VTEC solenoid, what everyone loves. If you actually want to create a little project of this, you can wire up a circuit to have a light enable when VTEC comes on, you can have a VTEC light. Then we're dealing with our logical grounds and our power sources, which is everything in this third column to the very right. Coming down, you've got your IACV, or your idle air control valve. This is what is responsible for your car idling correctly. It's located on the front of your intake manifold, and it allows a controlled amount of air to bleed through your intake manifold, which is what controls your idle. When you experience things like idle surging, commonly your IACV is responsible for that, and there's lots of documented pages on forums and online of how to clean your IACV and how to replace it if necessary. Moving along, you're getting into your evap emission stuff again, your fuel pump relay. So if you were to put in an aftermarket larger relay to run a larger fuel pump, you could tap it off of this output signal here so that you could have that control your relay. You've then got your AC compressor. So this is what is responsible for your aircon compressor engaging or disengaging when you turn on your aircon or turn it off. That allows it to not have a load on your engine when you're not using your aircon. You've got your malfunction indicator lamp, also known as your cell, which is your check engine light. This is what causes your dash to illuminate as the signal coming off of this. We've then got alternator control, which is just responsible for your alternator regulating how much power is being put into your battery to charge it, relating to your charging system. You've got your ICM, which is the circuitry responsible for controlling your ignition. So this is located within the distributor. It controls stuff like when the coil fires and whatnot. So then we're coming down to your IC sol and IAB sol. So what this is your intake control solenoid and your intake air bypass solenoid. So I believe the intake control solenoid is the one that's actually responsible for those little annoying butterfly systems that everyone seems to delete as soon as they get their first Prelude. So it's the box which is located in your bumper, and it's kind of like a resonator box to reduce intake noises. Your IABs, however, are your intake air butterflies, commonly referred to, and what they do is they adjust your runner length based on which RPM range you're in. So in some cases, you want to have a shorter runner length, or you want a larger running length, and there's benefits in RPM ranges for which one you have. So then we're just over into radiator fan control. So this is what controls the radiator fan relays. So if you were going to run a different relay, run a different setup, or if you were going to add a switch to have it so you can control when your fans go off, you could basically tap into this signal here, and you could push out your own signal, replacing the ECU, controlling it with your own circuitry. And then we're into evap emission stuff, which we won't really touch on because no one really seems to be interested in emissions anyway. So that's pretty much ECM connector A. It's not too complex. Mainly, nuance of interest on this is you've got your VTEC solenoid, which you could build a cool project off of. You've got your fuel pump relay, so if you want to check if the signal's being sent when you try to start your car, if you are debugging something. You've got your radiator fan relay output, so you can check if your fans aren't engaging, the signal's actually coming out of here. And then you've also got just your IACV. So if you've got a poor idle and you've narrowed it down so it's not the actual physical component, you can see that it's actually being controlled and a signal is coming out of the ECU here. And it is documented in the workshop manual what expected voltages are for this, and there's much more detail and much better information than this. So I'll actually include the page with the proper connector diagram and information on it, so you can have a read through that at your leisure. So one thing I forgot to mention before finishing off the last section is with ECM connector A, these are all either outputs or they're driving signals. So you've got driving your injectors, you've got your control for output for your heaters for your O2 sensors, you've got controls for relays, you've got logical grounds and powers. Technically, ground is an input, but we'll ignore that section. You've got things to control solenoids. So this section is really focused on outputs and driving. So there's nothing overly in here that we're going to be using on the Defi install, but it's useful information to have just out of curiosity. So moving along to our next connector, we're on to ECM connector C. So it may sound like we've missed B here, but on our ECUs we have ECM connector A, ECM connector C, and ECM connector D. So with this, like the last one, working from the top left to the bottom right, the first connection is a reference voltage. So what this is, it is a common reference voltage between our ECU, the TCM or transmission control module, and the ATTS module. Then we've got 3 lots of 2 with a positive and a ground for each of our crank position sensor, a top dead cylinder position sensor, and our cylinder position sensor. Then we've got our control for our aircon switch signal. So this is what happens when you press your aircon button. It sends a signal through to here, which basically then controls the output for the aircon from the last connector. There's then the starter switch signal. So this is the output from our ECU to have the starter fire. And then there's the SCS or the service connection signal. So what this is when you have that 2-prong connector that you jump in order for the check engine light to flash to tell you what engine code it is, this is where that signal goes to. Then there's K-line. K-line is a part of the OBD2 system. So we can talk about it in a separate video, but basically that is a common one that allows a bunch of information to come out of the ECU to that OBD2 connector. You then got your VBU or your voltage backup. This is what allows, even when power is disconnected, for a DTC check engine light diagnostic code to stay within the ECU. It's just a backup power supply. Sorry, I was wrong then. That's when the power is turned off, not fully disconnected, I should say. Then we're looking at our VTEC pressure switch. So this is a switch which is on the engine block itself that tells you how much, if there's enough sufficient oil pressure for VTEC. Then we then got our power steering pressure switch. We then have also an alternator control signal and our vehicle speed sensor. So our VSS, or vehicle speed sensor, is actually a sensor that we'll be using on our Defi install, and this is what allows us to tell us how fast the vehicle's moving. So that's actually a pretty important one there. So we'll take note of that wire, and we'll talk specifically about which color wire this is and how we're going to connect into this when we talk with that sensor specifically. We then have another one related to emissions, which we'll skip over, and the immobilizer code. So there's a lot of confusion around how the immobilizer system works on our Honda Prelude, specifically the 5th gens. And I'll do a separate video on how this works in detail. But basically, to sum it up, when you put your key in, a code is read off the key into your immobilizer box, and the immobilizer box talks to a chip on the ECU through this pin. Coming down to the bottom right here, there is your ATP and NP sensor switch, which is telling you if it's an automatic gear position sensor. So basically, what gear is the automatic in. And then we have some stuff related to comms, which we'll avoid at this point because we really don't want to get into too much detail. So that's pretty much ECM connector C. Again, I'll link the full document so you can have a read through it. It's just a nice high-level overview. So taking away from this sensor, we are interested specifically in pin 18, which is going to tell us our vehicle speed. So we'll tap into that. So before we move on from this section, this connector, I'll just go over some common debugging points if you are trying to look through problems and diagnose an issue with your car. So first of all, if there is no starter signal coming out of the ECU, obviously the starter isn't going to fire. So if you're having a look specifically at pin 6 here, you can check to see that whether you are, when you go to attempt to start your car, whether a control signal comes out directly from the ECU. Another one which may be interesting to you is you can check your VTEC pressure switch to see that a value is actually coming through to the ECU if you do not have VTEC engaging. More likely it's going to be an issue related to the VTEC control output, but that's also something that you could consider looking at. If you're having trouble with getting a vehicle speed out onto your actual gauge cluster, you can check your VSS to see if there is actually a signal coming out. And I believe that's mostly the ones that you'd be commonly debugging on this connector. Voltage reference may be of interest to you. There's an actual spec defined in the document that tells you what it should be if you are having some kind of weird funky issues. These more so, if you're looking at those specifically, you're going to want something like an oscilloscope because the signal that comes out of them is quite small because it is a actual real wheel rotated on the crank, which is spinning or within the distributor, and the output pulse coming out of them is quite large. Okay, so this brings us along to our final connector on the ECU, ECM connector D. Now, just in relation to the previous section, I realized I forgot to circle the pin which was related to our RPM or our crank speed. So I will highlight that specifically when we run through wiring up the individual connectors, so sorry about that. So starting again, going from the top left to the bottom right, we've got the TPS, or your throttle position sensor. Now this is a sensor located on your actual throttle body, which is on your intake manifold, and it moves along with your, there's a little flap that opens when you put your foot on the pedal and the throttle cable moves. And this basically just puts a voltage out to show how much the throttle is opened or closed. Then there's the ECT, or engine coolant temperature, which tells you how hot the water running through your engine is running, so the output from your radiator. Now, we won't be using this sensor for our water temperature sensor because the kit actually comes with our own, but this is one section when you could potentially wire something else to read how hot your temperature is running, provided you have the correct reference table. You've got your map sensor, which is your manifold absolute pressure sensor. So this tells you how much air pressure there is in the intake manifold. And from this, your ECU can infer how much fuel should be injected into the ECU in order to hit a desired air-fuel mixture. You then have VCC1, which is your sensor voltage specifically for your map sensor. There is your brake switch. So when you depress your foot onto the brake pedal, there's actually a switch located on the top, and that is what this signal comes through to. There's your knock sensor, which detects knocking or pre-detonation within your engine. It's the one located on the back of the engine block under the intake manifold that everyone always breaks when they take their intake manifold off, me included. There is the input signal for your primary and secondary O2 sensors. Now, I'm not sure on the specifics of this, but I know for a fact that my car does not have a secondary O2 sensor, so it may depend on your specific model. Your IAT is your intake air temperature. So I was actually wrong in my previous statement about barometric pressure, I believe, because what you can do is if you know the temperature of the air, you can work out using the density how much volume there is. So that's the temperature of the air coming into the engine. You've got your EGR lift valve solenoid, we'll ignore that because again emissions. VCC2 is responsible for your voltage for the rest of your sensors, for other sensors. You've just got some signal grounds, we'll ignore them. We've got the fuel tank pressure, so that's how much pressure is actually in your fuel tank, because there is a whole half complex venting system for that, so that you don't want to overpressurize your fuel tank. And your ELD, which is your electrical load detector, and this detects how much electrical load there is. And you will see it increase with stuff like putting on high beams and stuff like aircon fans enabling. We can talk about it if anyone's particularly interested in. We can go through how the ELD operates, but for now, that's the overview of the ECM connector D. Hopefully that though going through those connectors with you is somewhat useful. If you want to actually have a look at these connectors in your car, the ECU is located in the passenger footwell. Move the carpet back and there will be 4 10mm bolts which hold a plate in place. Undo those bolts and it will fold forward. Be very careful not to damage the wiring when you do this. And you'll see on the left will be your ECU, and on the right, if you have an automatic, will be your transmission control module. You carefully remove the connectors from the back of the ECU. You'll see connector A, C, and D there, and you can associate them with the information I've just shared. So at this point, don't worry about wiring anything in, because we'll talk about the specific pinouts when we go through each sensor and how we're going to wire it in.